Okay, so what we're going to do today, guys, with arcs and angles as rotation, deals a lot with how many degrees are in a circle. Does anybody good? 360 degrees are in a circle. Now, one full rotation to make a circle, okay? So if you drew one whole rotation and completed a circle, how many degrees would that be? Oh, 360. Now, if you did two rotations, let's say I kept this going, but I made another rotation. How many total degrees would that be?
720.
Good. 720 degrees would be in two rotations. 7, how'd you get that?
360 plus 360.
Good. So have I lost anyone yet? You're lying again. Okay. So when we deal with something called standard position, all that means is we're looking to see where would the ending of the degree measurement be, like where would it stop, okay? An angle in standard position, right? You can think about, the easiest way to think about this, guys, in something in standard position, okay, it always starts at the x-axis, and then it ends, the terminal side, this is going to end where the degree is. So if we're going to draw something in standard position, what we're always going to do is we're going to start at the x-axis and we're going to end wherever you guys think the degree measure would be. Okay? This picture that you guys see down at the bottom is where we're going to do our drawing. This is something you guys are going to see a ton, like almost every day when we're in trig. Okay? What this is a circle, but notice it's over an axis. And you guys said a whole circle would equal 360 degrees. But if you split it into 4 quadrants, what does each little quadrant contain? 90 degrees. Good, so this is like 90 degrees, this is 90 degrees, because they're all equal. Now, in your quadrants, this is your first quadrant, right? This is your second, third, and fourth. Yep, okay. All right, so when we're going to draw some of these angles, we're not going to actually get out a protractor and like have to measure super accurate. But you want to make sure you're in the correct quadrant where you're ending. Right? So if I had something like an angle of 160 degrees in standard position, okay, you always want to start at the x-axis, or like where 0 would be. So we are going to 160 degrees. Let me know where you guys think I should stop. Yeah, that would sound good. Yeah, perfect. I like the B thing. Okay. That's it. You're done. That's standard position. Okay. And again, am I going to actually like, get out a protractor and measure this? No. You just need to make sure 160 has got to be between 90 and 180, so we can stop around there. Okay.
Wait. What's right over 180?
This? I think you already have it on yours. Is it?
Yeah,
Yours is already.
Oh, it's just a 3.
Right,
Okay.
yeah, quadrant 3. Nope. Okay. Now, same deal, if you guys were going to go to 270 degrees. So again, we're going to start at 0. If you're going to go to 270, then we'd have to go all the way around. Where do we end?
At 270.
Oh, perfect. Right at 270. Oh, gosh.
Oh no, that's like 271.
Oh no. Okay, there we go. It's right on the line. If you guys get something that's right on the actual line, it's kind of special. It's called a quadrantal angle. It's not something really important, you know, but it's a big deal. Anybody's curious what that's called. Okay. Now, if we had something though that's negative in degree measurement, that affects the direction. Yes, yeah, we're going to go the opposite direction. Good. So everything, when it was a positive degree measurement, we went up. But if it's a negative one, we're going to go down. And it's really important you understand that in each of these quadrants, there's 90 degrees.
Do you go the opposite way, like start at 180?
No, we still start at 0. Good question, yeah. We're still always going to start at 0, except we're going down, exactly, actually. So if you're going down 80 degrees. Oh, good, perfect. Nice job. That's like where negative 80 would be. Nice. Because if you went more than this, remember there's 90 degrees in here. If we went past this, we'd be going past where a 90 degree angle would have been.
So 90 technically like 270.
Yeah. Oh, you're gonna love what we're doing next. You keep that in mind. Yeah. All right. Let's just make sure we're okay with sketching. Why don't you guys take a second, check out what 190 degrees, draw it in standard position. All right. See what you think it would be. Does anybody want to use the smart slate?
Crouch down.
Not to sketch angles.
Yeah, you want to show it? Great. How you work?
Why don't you set it in the middle right here?
Oh, just
Like, like do you set it here?
No, you start
here. I usually that, so I have lines on top of lines.
No, you gotta clip.
So how would I do that? Like,
You have to clip.
Oh, you don't.
Girl.
Yeah,
start
there's like a pen up there, you
so
gotta
you
press
always have to start.
on the X.
Over.
Yeah, doesn't matter what spot.
No, that big one.
Oh, click on this, or one of these.
Oh, like bring
It should be okay.
Like,
They're just trying.
oh, oh.
That's not 119.
Well, she said draw a circle, that's what I was doing.
Oh, actually,
Don't confuse me, actually.
so all you have to do right there.
That was so embarrassing.
No.
Like, that's cool.
Kim, you don't have to go to
Yeah,
church.
trust me.
Oh.
Instead of 99, oh my God.
Come on.
Oh, you have to show it that like
Are you having trouble, Chelsea?
This is a different subject, maybe I'm better.
Yep, good.
119, draw an angle straight from the end. Other side.
Yep, yeah.
Use my word. Do it right there. Do it. Right. Right there.
Yeah, that looks good. And then just make sure, guys, you like draw your ending part right here.
Yeah.
Okay, so that's like your 119. I'm just gonna make that sure that it touches the x-axis. Good job, Charlie. Now, guys, one question I had when I was walking around: does it matter where you start on the x-axis?
No.
No. You could have gone. Chelsea could have did it right here and said this was an angle 119. Totally fine. It just matters like where you end. Okay. The start just has to be on the x-axis. How are we with drawing? Were we all able to tell where 119 would have been? Around.
Yeah.
Great. Okay, flip it over. All right. So the next idea is something called coterminal angles. And Chelsea, this is like, you were right on the idea of this next step. Okay. Now, coterminal angles means that when you draw two angles in standard position, okay, they have the same terminal side. All that means is they end in the same spot. Right. So it just means if we drew two angles, if they can end in the same spot, it means that they're coterminal. What we mean by that, you guys can kind of look at this little example here. Just keep in mind, if you have a positive degree measurement, we're going to go up. Right, when we go to draw a picture, if it's something that's negative, we're going to go down. Yep, exactly. Clockwise and counterclockwise in the case here. So if we have something that was like 120 degrees, okay, all that means is we would graph 120 in standard position. There we go, there's our 120. Now we would want to find an angle that could end at the same spot. Right, to do that, and there's lots of ways we can handle this. There's more than one correct answer. Okay. We can go downward to get an angle that would also end at the same position. Right? Brittany, I think you were kind of on the right track here. What would this complete? Think about if you were going to, who said that? Lily, what would it say? 360 degrees. See how this together would make a circle? If they end at the same spot, it creates 360 degrees. So one way you guys can get a coterminal pretty quickly is using like 360 degrees. If you take 360 and I subtract the 120, I get 240 degrees. But you just have to make sure we can't go positive 240 because positive 240 would have been somewhere in here. You want to go negative 240 to end. So drawing a picture sometimes really helps to see if you're going to be a positive or a negative. Now that's just one answer, right? Negative 240. Other things you guys could get, and Devin, I have a feeling you're gonna like this. Yeah. Okay. So imagine if you guys, right, here's 120. That's where we want to get to. If you know a full one is how much? 360. How many, okay, so here's 360, right? How much more would you have to go to get to this? Another 120, good. So really, if I take 360 and I add 120, this would give you guys 480. So you could also do something bigger than the angle. If I graph 480 degrees, that's going to also end at the same spot. So you could have multiple things. We could go around 3 times and end there, right? There's more than one answer. But the idea is that you guys are really familiar with that one rotation, 360 degrees. You want to think, how else could I get to that point? Yeah, Devin.
Since each circle is 360, when you go to that 120, would that mean that the rest of it, the rest of it would be a negative 240 again?
Yeah, yep, exactly, because you would have to go down 240 to end at that same spot. Yep. Yeah, you always make sure you're ending at the same position every time. That's what coterminal is. And, you know, if this comes up, guys, it's usually a multiple choice question where they'll say, you know, what angle is coterminal with negative 10 and give you 4 options. The big thing is if you can physically graph it and you know that it ends in the same spot, it's coterminal. So for number 1, and I like pictures. Some of you guys who are really good at just doing numbers out, you can probably do this without drawing a picture. But if you're a visual person, you might want to. So we have something that's negative 10. Okay, that means what direction would you guys go? Down. Down just a little bit, right? Down 10. Okay. So now if we wanted to go to the other direction and meet it, how much around would we have to go? You were thinking 350? Ashley, how'd you get 350 so fast? Absolutely perfect. Good job. Right? 360 is kind of like your key here. So if we took 360 minus 10, we know we'd have to go 350 degrees the other way to meet it. Good job, Ash. Perfect. So 350 degrees would be something coterminal. Now, let's see what other things we could do. Could I go down and do, see, that'd be 360 and then another 10 and make it negative 370? Would that also end at the same direction? Yeah, you'd be going one full time around to be 360, and then that extra little 10, you're going to go the down direction and make it negative 370. Well, we did negative 10, that was your original, right? Okay. So if you want something that ends at that same spot, then you can go up and then there to get 350, or see the stuff in the red. Okay, so you can go one full rotation, which is 360. Then how much more would you have to go? 10 more, but you're still going down directionally. That's why it'd be like still negative. Alright, let's try another one. And again, like, you guys don't have to give both of these answers. Only one of them is going to like be on a multiple choice. But it's good for you guys to know that, you know, you don't always have to just, you know, subtract from 360. Sometimes you can go a full rotation a little bit more to get something coterminal too. So for 540, let's see, can I draw something else? We know that, oh good, so 360, and then Aunt, how could you tell how much more you had to go? Yeah. 540, good, Aunt, minus 360 was what? What did that make? Get 180? Okay, so if we did 360 to get to 540, we have to make another 180. And so here is where 540 would be. We want to think about what we can use for degree measures that will hit that star. Ooh, Brittany, love it. Okay, so you did negative 180, so going down. Right, good, negative 180 would hit that. Very nice. Anybody have another one? Think about a positive direction. Positive 180 is also going to be there too. Yeah. Right, that'll also end at the same spot. And so those are